Okay, for each sentence, write a conditional statement and then write the converse. Very simple. On many of these, all you have to literally do is put if and then in them. But sometimes it doesn't make sense. If math teachers want, then students do, it doesn't always work. Okay? So sometimes you can't do that. Sometimes you have to change words or tweak them a little bit. So, if you are a math teacher, you not mean to put a comma there, teacher, I just going to give up on that word right there and start over. Math teacher, then you want students to succeed. Okay? Students to be successful, students to succeed, whatever. You can kind of change the words a little bit. Then for the converse, all you do is take this part and move it with the then, and this part and put it with the if. That's all. You just switch sides. So it becomes if you want your students to succeed, then you are a math teacher. Now, this does not ask you to evaluate true or false, but if you looked at this, you would say, no, it's false. And if asked to prove why, you just come up with a reason why it would not be true. Like, I could be a science teacher and want my students to do well. I could be an English teacher and want my students to do well, and so forth and so on. That would disprove it. Okay. If an athlete then never missed practice, well, then he's like a caveman. So you kind of need to worry, add a little bit more. If you are a summit athlete, then you never miss practice. Again, all you have to do is take the if part and the then part and then flip it around. If you never miss practice, then you are a summit athlete. And if asked to evaluate, you would say the converse is false, because you could be a Eureka athlete, you could be a middle school team athlete, you could be on a select team somewhere outside not even school and never miss practice. So that would prove it also false. Okay. Facts about the angles, and you can use pictures. So these are very important. You should know these by now. Vertical angles are formed by an X, intersecting lines. Okay? And the key here is opposite angles are congruent. So these two are congruent, and those two are congruent. Okay? Always. Now, you don't have to have the exact same thing I have written down here. Just a general idea. You got to know that vertical angles are opposite of each other, and they are congruent. Linear pairs. That's a horrible line. Linear pairs almost always, in fact, I think every time you've seen them so far, except maybe one problem, we're always with an acute angle and an obtuse angle. Okay? So, acute, obtuse. The only exception would be this, if you had two 90-degree angles. Otherwise, most times they're going to be acute and obtuse. And they're going to be supplementary. Or they add up to 180 degrees. Something like that. Okay, corresponding angles. Corresponding angles. The key here is one in, one out. Now, I'm going to be talking for the rest of these about parallel lines. Because if they're parallel, then they are congruent. Now, if they're not parallel lines, and that can happen, we can have that, we can have like this and this and this, well then this and this are, those two angles are corresponding. They're not congruent. Hopefully you can clearly see that those are not going to be the same measurements. But they are corresponding. But for what we've been doing for the most part, we've been talking about parallel lines, back and forth, and we've been talking about them being congruent. But still, either way, 2 is inside and 1 is outside. Just remember that. That's the biggest part right there. 1 in, 1 out. Alternate exterior. The key here, and I'm going to deal with parallel lines. Key thing here is one's on this side and one's on that side. Okay? So both sides of transversal, that's key. That's very important. They got to be on both sides of transversal. And if the lines are congruent, I'm sorry, if the lines are parallel, so we use this symbol, parallel lines, then the angles are congruent. If the lines are parallel, then they are congruent. If they're not, then still, like I said before, you can have this and this. Let's try that again. You can have this, and there's your transversal. Well, there's 1 and there's 2. Those are alternate exterior. Oh, that's the other key too. They're both out. They're both outside. They're both outside the lines. One on the left side, one on the right side of the transversal. So 1 and 2 here are not congruent, but they are alternate exterior. Okay. Distribute. All we're doing is sending this bad boy in, so we got 2x minus 12. Hope you got that right. We're entering into flu season. I just realized on my own, with no help from anybody, that I skipped a couple. Okay, I'm lying. Consecutive interior angles. Consecutive interior angles, key thing here is they are the same side. In fact, you remember from the other notes, the old term for these angles were same side interior. They are also inside. And if the lines are parallel, these are not equal to each other. They are supplementary, which means they have 180. Then we have alternate interior angles, so of course I'm not going to forget those. Boom. Very similar alternate exterior. We have 1 here and 1 here. So they're both in. And if the lines are parallel, then the angles are congruent. If they're not parallel, that's okay. They're not congruent, but they are on opposite sides of the transversal. Okay? That's the key thing here. The word alternate means, left and right side, every other part. Okay? Now, back to the part before I skipped. Number 10 is kind of like we're entering the cold season. If Amy gives Brad a cold and Brad gives Caroline a cold, it's really kind of like Adam gave Caroline a cold, right? Because that's where it originated. So that's what the transitive property is. So angle A is congruent to angle C by the transitive property. Okay? Addition, all we're going to do is add 6 to both sides. So we get 2x equals 26. That's all. Okay, basic proof. Okay, algebraic proof. So, first thing we do is write down what was given to us. Plus 5, 3x minus 4 equals 3x plus 6. And that's given to us. Okay, next thing we're going to do is distribute. I'm going to distribute both, so I only have to distribute one time. So I get 7x plus 15x minus 20 equals 3x plus 18. I just have to write distributive property once. I distributed twice, but I did it in the same line. Did it at the same time. Okay? Now, next step is combine like terms. So I get 22x minus 20 equals 3x plus 18. The technical thing you should write here is substitution. Many of you probably wrote combine like terms, which I will accept. But I want you to understand that you're substituting in 22x for 7x plus 15x. Okay? If you wrote combine like terms, that's fine. I'll accept it. Okay? No points lost. Now, I'm going to move my x's over to the left because I have more x's over here. So I'm going to move to the left. I'm going to minus 3x. Which means I'm going to do what with the 20? Well, I'm going to add 20. So since I'm adding 20, I can't do it on the same line. If the 20 was positive, I was subtracting 20 from both sides, I could do both at the same time and then write subtraction property. But since I'm doing one of each, I've got to do it on separate lines. So 22 minus 3 is 19x equals, minus 20 equals 18. And that's the subtraction property. Now, I'm going to add 20 to both sides, which is the addition property. And you can abbreviate anywhere you want. Which gives me 19x equals 38. I'm going to divide by 19. And I'm going to get x is 2. So that's the division property. And then once you prove, some of you are putting a check mark here, some of you are writing the word proven. Either one of those is fine, but give some indication that you know you're done. Because you got that. I don't write prove, because prove is what you're supposed to do, and you've already done it. So either put a check mark or write proven, because you got it. Okay, so if you ever have a situation where you run out of room, you can always just add another T-chart and just continue wherever you were right there. You don't have to like rewrite it on that or anything crazy like that. All right, very basic. You want to make this right here look like this. So the big clue is, I told you in class today, is look at the signs. The positive y needs to become negative. The positive 3x needs to stay the same. So you're not going to touch that. And the negative 4 needs to become positive 4. So in other words, if you're changing signs, that means you're moving sides. You might have learned when you were in grade school or middle school, change sides, change signs, kind of thing. So y equals 3x minus 4, that's given. So the first thing we know is, well, we need to, some people might move the 4 over, some people might move the y over. And I want to do that because I want to show you what happens. Subtraction property. If you didn't do it this way, if you move the 4 over, that's okay. But here's the interesting thing. Some people don't know what to do when they do this. They're like, oh, everything's gone. Maybe the equal sign is gone. Maybe it's just 3x minus 4 or minus 1. No, it's not. It's 0 equals 3x minus y minus 4. Well, look. Here's that 3x minus y we needed up here. Only thing we need to do is move this bad boy over here by the addition property. That gives me 4 equals 3x minus y, and we're done. Now, somebody asked me earlier, are we really done? Because it doesn't look exactly the same. And if you really want to be top-notch, and that's great, you could say 3x minus y equals 4 by the reflexive property. And then you would hit check mark. Either way is fine. Okay, moving on. Fill in the blanks if you're reading answers or numbers. Now, this one, really most of these are good. There's only one problem. Number 13, this really should say 21, not 22. Because if you look at 22, it's clearly an obtuse angle. say too clearly. It's probably like 95 degrees, but it's obtuse. It's definitely nowhere near the size of 35 degrees. So I know that throws some people off, and I understand that. I'm OCD, that bothers the heck out of me. But we're going to say 22 and 35. No, 10. 35 is so we use the knowledge that we've been doing so far, and we can say, well, I'm going to drop, you don't have to prove this, we're not doing proofs, but the logic in your brain should be walking through what we've been doing. 22 goes to 14 by corresponding angles, 14 goes to 10 by corresponding angles, which means this is also a 35. Okay? Now, once again, you could have gotten there many different ways. You could have gone from 22 to 15 by alternate exterior. And then you could have gone 15 to 10 by alternate interior. Okay? That would have worked too. There's a lot of different ways to get there. But basically, you want to remember in these problems, when all lines are parallel, basically the most important thing is all the obtuse angles are equal and all the acute angles are equal. So even though 35 is not obtuse, you know that every obtuse angle here, every single one, is going to be the same. It's going to look like that. You can know that right off the bat. If you have parallel lines, it's going to be like that. And therefore, every one of the acute angles, vertical and so forth, whatever reasoning you use, corresponding, alternate interior, all of these little angles here are going to be equal to each other. You know it every time. Okay? So if you have one obtuse and one obtuse, they're always going to be equal. If you have one obtuse and one acute, you know they're going to be supplementary. Okay, I want to erase these just so I have more stuff to mark with. So 19, angle 1 and 4. So 1 and 4, clearly you should see those right away and go, boom, congruent, because they are vertical. Also don't forget to put the angle symbol. Okay, these are 19 angle degrees. Okay, don't put just 19, because otherwise I don't know if it's 19 orangutans or 19 sheep or 19 degrees. Put the degree symbol. 21 and 22. Well, here's 21 and here's 22. Here's the other circumstance. These two are side by side. These two form a linear pair. These two form a straight line. This is the one time that they're not going to be equal. They are going to be 180 minus 94, which is 86 degrees. So remember, when you see an acute angle and obtuse angle, they're going to be supplementary, most likely, in this case. At least in this chapter that you're learning, it's always going to be the case. With parallel lines, of course. 18 and 15. Here's 18 and here's 15. Well, if we look at it closely, here we have two lines. Here we have a transversal. 18 to the right, 15 to the left. They're both exterior. Alternate exterior are congruent. And therefore, this is 95 degrees. Now, technically, somewhere up in the instructions, there should be something saying assume all lines parallel, or they should say A is parallel to B, M and P are parallel, or they should have the little triangles on them. Okay, they should be marked like this. Okay, but they're not. But technically, they should be. Where's the color? 11 and 22. Here's 11. Here's 22. But once again, we can get there any way we want. But notice, obtuse, obtuse. You know they're going to be equal. Okay, you just know it. Save yourself time. Well, I could say 11 to 15 by corresponding, and 15 to 22 by alternate exterior. You should be kind of in the habit of these proofs by now, how to reason them out. Measure of angle 4 is 29, then what's 7? So here's 4, here's 7. Again, here's your lines, here's your transversal, 4 and 7, one inside, one outside, corresponding, which makes them equal to each other. Congruent. Same number. Okay, you guys can look here. I'm not going to do this back and forth because it's going to like lead to seasickness. So you can look at your paper and find these. 1 and 7 are alternate exterior. Okay. Make sure you're looking at these and find out where the lines are, find out where the transversals are. Okay? 24 and 20 are corresponding. 20 and 13 are alternate interior. 20 and 14 are consecutive interior, also known as same side interior. 11 and 12, formal linear pair. I would also accept the answer supplementary. You put that here. I would take that. Vertical for 14 and 15. You can also abbreviate vertical. V, R, T is fine. And 19 and 15 are corresponding. There we go. Okay, solve for x and the missing angle. Now, once again, guys, especially in this page, think about the fact. If you have two acute angles, or two obtuse angles, they're going to be set equal to each other. If you have one acute and one obtuse, they're going to be added up to 180. I should not be seeing, like in this circumstance here, these are clearly corresponding angles, which means they're congruent. I should not see 3x plus 18 plus 4x plus 12 equals 180. Shouldn't see that. I should see 3x plus 18 equals 4x plus 12. I went right to the distribution. If I move over my x's over here, I get 1x. Move the 12 over there, I get 6. Now, some people had some problems the other day doing this. They did 4 times 6 plus 3. If you're going to distribute the 4 first, which is not recommended, it's 4 times 6 plus 4 times 3, which is 24 plus 12, which is 36 degrees. The simplest way is please excuse my nationality. 6 plus 3 is 9, times 4 is 36. Okay, here, we're trying to find b, and we're also trying to find x. Well, this is acute, this is obtuse. But remember, by substitution, we know that these two are the same by corresponding. B and 5x plus 6 are corresponding, which means they're equal. So by substitution, we can put it in there and say that this one plus this one equals 180. Then we combine like terms, we get 8x plus 8 equals 180. 8x equals 172, and x is 21.5. And that is okay. So yeah, decimals are our friends, and it's okay to get a decimal. When you plug it back in, you get 113.5, don't forget degrees. Now remember, we're looking for b. Since we know, there's two ways to do this. We could plug in the 21.5 there, and then subtract from 180. The easiest thing, though, would be to plug it in right here, since we know that that is equal to b. Okay. Again, you have an acute angle here and an obtuse angle here. You pretty much know what that should be in this situation. We know that you should set them equal to 180. But why is that? Let's prove it. We have a line here, we have a line here, we have transversal. Everything's marked parallel. Okay? So, both, I'm sorry, I went the wrong way with my lines. Whoops. I'm all over the place. Here's a line, here's a line. These both angles are on the same transversal right there. Well, this acute angle and this obtuse angle are both inside, and they're on the same side of the transversal, which makes these two angles consecutive interior. And we know consecutive interior are supplemental. But again, just using common sense, in this situation, in this chapter, when we see an acute and obtuse, we know that they are going to add together to equal 180 degrees. Combine like terms, 15x minus 15 equals 180. I'm going to add 15 to both sides and get 195. And when I divide by 15, I'm going to get x is equal to 13. Well, again, where do I plug it in? I'm going to plug it in right here because I know that this is my other obtuse angle. Now, again, we can prove that by saying C and 12x plus 1 are consecutive interior. But we know that it's going to be the same thing. So if I plug in 3 times 13, that's 39, minus 16, that's 23 degrees. Okay, number 29. Well, clearly you can see here's my two lines, here's my transversal, one inside, one outside. We have corresponding angles, which means they are equal. So 6x minus 18 I distributed equals 4x plus 4 I distributed again. Subtract 4x, add 18, divide by 2, x is 11. Well, the measure of angle D is vertical to 4x plus 4 times x plus 1. So if I plug the 11 in, 11 plus 1 is 12, times 4 is 48. And they're going to be equal to each other. Find the measure of x so that the lines are parallel. Well, if the lines are parallel, these are consecutive interior. Again, look at it. Obtuse and acute. You're not going to set them equal to each other. I should not see x plus 8 equals 2x plus 1. I should see 2x plus 1 plus x plus 8. This angle plus this angle add up to 180 because consecutive interior are supplementary. Well, that gives me 3x plus 9 equals 180. Subtract 9, I get 3x equals 171. Divide by 3, and I get 57 degrees. No, sorry, 57 for x. Now, it did not ask me to plug in and find the angles of this problem. All I'm doing is finding x. But I could plug in 57 and find both those angles, or either one. So here's my lines. I'm trying to prove that they're parallel. If they're parallel, then these are alternate interior, which means they are equal to each other. I distributed my 5. I distributed my, well, sort of distributed, with another equal sign. Distributed my 4. Subtract 4x, and I get 1x. Add 15, I get 3. That's my answer. Now, once again, this is one of those problems where plugging it back in doesn't work because I get 0 degrees for both. Both of these are equal. Okay, last few problems. Now, write a proof. We're trying to prove that 22 is congruent to 11. There's 22, there's 11. Again, we have many ways to get there. You can go from 22 to 3, alternate exterior, and 3 to 11, corresponding. We go 22 to 2, corresponding, and 2 to 11, alternate exterior. And we can do the same thing going down this way. 22 to 14, which is corresponding, and 14 to 11, alternate exterior. 22 to 15, alternate exterior, 15 to 11, corresponding. There are so many different ways to get to this proof that 22 and 11 are the same. That's just a few of the many. So, A is parallel to B, and M is parallel to N, which is parallel to P. That's given. So, I'm going to just pick one way to go. I'm going to take angle 22. Is congruent to angle 3 by alternate exterior. Again, I can't just write that. So I use my symbols. if lines are parallel, alternate exterior angles are congruent. That's the most abbreviated way to write it. Then I'm going to go from angle 3 and say it's congruent to 11. And say again, if the lines are parallel, corresponding angles are congruent. Then I just tie it all together. Angle 22 is congruent to angle 11. And that's by the transitive property. And again, you can put a check mark, or you can just write proven if you want. Okay, same drawing. I'm not going to scoot back up and forth. Reason. Again, A is parallel to B, and M is parallel to N, which is parallel to P. That's my given. We're trying to prove 18 is supplementary to 12. I guess I'll go back up once. So we're trying to prove that 18 here is supplementary to 12. Well, if you think about it, 18 is obtuse and 12 is acute, so that makes sense. If all lines are parallel, all the acutes here should be supplementary to the obtuses. Okay? Now, how do we get there? Well, we want to ultimately say that 10 and 12 are a linear pair and substitute. So basically, we're trying to prove that 18 and 10 are the same. So we're just going to bounce either 18 to 6, then 10, or 18 to 14 and 10. Doesn't really matter. I'm going to drop down and say 18 to 14, 14 to 10, 10 and 12, 18 and 12. Okay? So here we go. We're going to say that angle 18 is congruent to angle 14. Again, if lines are parallel, then corresponding angles are congruent. Then I'm going to say 14 to 11. Oh, you can do that. Or 14 to 10. I'm going to go 14 to 10. You could do 14 to 11 by alternate exterior. I'm going to go 14 is congruent to angle 11. Sorry, I said 10. Bouncing back and forth. Again, 14 and 10 are corresponding. So I'm fine with you just doing that, because it's the exact same justification. Parallel lines, corresponding angles. Then I'm going to say that angle 14 or angle 18 and 10 are congruent by the transitive property. And then I can say that angle 10 is supplementary to angle 12. Sorry. And that's because linear pairs are supplementary. That's how you justify it. And then I can say angle 18 is supplementary to 12. And that's by the substitution property. And again, there's so many different ways you could go with that. But basically, you want to just get to its next door neighbor, and then prove linear pairs, and then substitute. Okay, 33. Emily goes to math lab on Tuesday morning for the first half of the semester. You conclude she'll always go to math lab on Tuesday mornings. Okay? So that's going to be inductive reasoning. Because you went from small, even though half a semester is about a bit of time, you're going from the small or the specific to the general, always. Well, she went for this part, so she's always going to go. We know that all geometry students practice their math skills. Since Bennett is in geometry, he practices math skills. That's deductive reasoning. You started big and then went down to one person. Every Summit student you have met has school spirit. Okay? Now you notice you see the word every, it's only the ones you've met. Then you conclude that all the students have it. So you're still going from a specific group that you've met to the general of everyone in the school, and that's inductive reasoning.